In this video, we will see an example based on the decision making under uncertainty. So before we start with our example, firstly, let's discuss the types of decision making environment, which are certainty, uncertainty, risk, and conflict. The first one is decision making under certainty, in which the decision maker has the complete knowledge of the consequence of every choice with certainty. Then the second one is decision making under risk, in which the decision maker has less than the complete knowledge with certainty of the consequences of the course of action. Then the third one that we have is decision making under uncertainty. Here the decision maker is unable to specify the probabilities with which the various states of nature will occur. And for this decision making under uncertainty, there are several different criteria of decision making, which we'll discuss further. So the first one is criterion of optimism, which is Maximax or Minimin. Then second one is the criterion of pessimism, which is Maximin or Minimax. Then the third one is the Laplace criterion, which is also asked as equally likely decision. While we'll be solving the sum, I'll make it clear to you how we can find all these criterions. Then the fourth one is Minimix regret criterion. And the last one is HURWICZ criterion. Now this is the question. The payoff matrix containing the different strategies and the events, that is the states of nature, has been given to us, and it is asked to find the decision that will be taken under the following approaches, which is optimistic, pessimistic, equal probability, Minimax regret criterion, and HURWICZ criterion, where the degree of optimism is 0.7. Now to answer the first question, which is optimistic, we'll either find the Maximax or Minimin. So here we'll just find the Maximax. It can be asked to you like to find the Maximax directly, or they will ask you to find the optimistic. So over here it is written as optimistic. We'll find the Maximax. For that, you'll have to make a table again. Over here, you will write the strategies, which is S1, S2 and S3. And on the left side, you will write the states of nature. Because our strategies are our course of action, and for the course of action only we'll find the maximum or minimum values. So that is why we have changed this table and wrote it like this. Now I'll just write the row values in the column values, which is 4,000, minus 1,000, 6,000, 18,000. Then the second row values will be written in the second column, which will be 20,000, 5,000, 400 and 0. It can be written as strategy or it can be written as course of action. Now the third row as the third column, which is 20,000, 15,000, minus 2,000 and 1,000. Then after, we'll find the maximum value for each of these three columns, as we need to find the Maximax criterion. So here I'll write it, column maximum. And for the first column, our maximum value is 18,000. Then for the second column, it is 20,000. And for the third column also, it is 20,000. Then after, from these three values also, we'll find the maximum value. So here we are having two maximum values, which means that the decision maker can either adopt the strategy S2 or S3. So the answer to the first question is S2 or S3. Now for finding the answer to the second question, which is pessimistic, we'll find the Maximin Criterion. Here it is written as pessimistic. In many of the questions it will be directly given to you to find Maximin Criterion. So we'll just see this, how we can find Maximin Criterion. For that, the table will remain the same as we have made for the first question. Here only we'll write it as column minimum. Now for each of the column we'll just find the minimum values. So for the first column it is -100, for the second it will be 0, and for the third it is -2000. From here you need to find the maximum value. So from these three values our maximum value is 0. Hence the decision maker will adopt the strategy S2. The answer to the question 2 is S2. Then our third question is equal probability. Equal probability, which means Laplace criterion. It will be directly given in the question to find the Laplace criterion, or it can be written like this to find the equal probability. So for that we'll make a table like this, in which here we'll write strategy and here we'll write the expected return. That is the expected return for each of the strategy we'll find. So the strategies are S1, S2 and S3. Now in order to find the expected return, here we are having 4 values. So we'll have to consider the equal probability, which is the probability will be 1 by 4. If you are having 3 values, then the probability will be 1 by 3. So we'll multiply 1 by 4 with each of these values of the first row, which is 4000 into 1 by 4, -100 into 1 by 4, 6000 into 1 by 4 and 18000 into 1 by 4. Then after we'll add all these. So we can write it as 1 by 4, we can take it as common, and 4000 minus 100 plus 6000 plus 18000 into 1 by 4. Same way we'll have to find it for the second strategy and for the third strategy. So for the second strategy it will be 20,000 plus 5,000 plus 4,000 plus 0 into 1 by 4. And for the third strategy it will be 20,000 plus 15,000 minus 2,000 plus 1,000 into 1 by 4. Then on solving these, we get the values as 6975, 6350 and 8500. From all these three values, we'll find the maximum value. So our maximum value is 8500. Hence the decision maker will adopt the strategy S3. Now our fourth question is Minimix regret criterion. Let's see how we can find the Minimix regret criterion. So the table that we'll make is like this, which we made for the first and the second question. Over here, from each row, you will find the maximum value. So as we can see that for the first row, we have two maximum value, which is 20,000. The value is the same, so that won't matter. Then for the second, the maximum value is 15,000. For the third one, it is 6,000. And for the fourth one, it is 18,000. Now just make a table like this, states of nature and strategy. That is S1, S2, S3, and over here it will be N1, N2, N3 and N4. Then we have already found the maximum value for each of the row. What we'll do, we'll subtract each value from that maximum value. that is 20,000 minus 4,000. Then 20,000 minus 20,000. And the last value again, 20,000 minus 20,000. Same way for each of the row, we'll do this. So for the second row, our maximum value is 15,000. Hence it will be 15,000 minus 100. Firstly, I'll just write this. This comes out to be 16,000, 0, 0. Then for the second row, it is 15,000 minus 100. I'm writing it this side. Then 15,000 minus 5,000. And then 15,000 minus 15,000. So this comes out to be 15,000 minus 100, which is 14,900. Then this will be 10,000. And the last one will be 0. Then after for the third row, our maximum value is 6,000. So it will be 6,000 minus 6,000. Then 6,000 minus 400. And 6,000 minus 2,000, which will be 6,000 plus 2,000. We get the values like 0. Then after it will be 5,600. And the last one will be 8,000. Same way for the fourth state of nature, we'll find. So our maximum value is 18,000. Here it will be 18,000 minus 18,000. Then 18,000 minus 0. And then 18,000 minus 1,000. So it will be like 0, 18,000 and 17,000. Then after our next step will be to find the column maximum. So again for each of the column you'll find the maximum value. The first column in which the maximum value is 16,000. Then for the second column our maximum value is 18,000. And for the third column our maximum value is 17,000. From this also we'll find the minimum value, as we need to find the Minimax regret criterion. So once we have found the column maximum, we'll find the minimum value. From these three, our minimum value is 16,000. Hence the decision maker should adopt the strategy S1. So the answer to the question 4 is S1. Now we'll solve our last question, which is the Hurwicz criterion, and the criterion of optimism given to us is 0.7. So for this, the criterion of optimism which is written, that will be our alpha. So alpha will be equal to 0.7. And now the equation to find this is alpha into best payoff plus 1 minus alpha into worst payoff. Now how we can find this best payoff and worst payoff? I'll just show you. So in order to find the best payoff, as you can see over here in this table, which I have written with pink color, this maximum value will be your best payoff for the first strategy. So 18,000 is my best payoff, and this minus 100, which is the minimum value in the first strategy, that will be my worst payoff. Same way for the second strategy, the best payoff is 20,000 and the worst payoff, which is the minimum value, is 0. Then for the third strategy, My maximum value is 20,000, that will be my best payoff, and minimum value is minus 2,000, that will be my worst payoff. Now, to find the Hurwicz criterion, we'll find it for each of the strategies. So I'll write it for S1, which is 0.7 into 18,000 plus 1 minus 0.7 into minus 100. So on solving this, we'll get 12570. Then same way for the second strategy we'll find, which is S2, 0.7 into best payoff is 20,000 and worst payoff is 0, plus 1 minus 0.7, that is 0.3 into 0. On solving this, we get it as 14,000, and for the third strategy, which is S3, it will be 0.7 into 20,000 plus 0.3 into minus 2,000. So it will be 13,400. That is, here we have not made any other table. This table we have used that was given in the question. Now our maximum value will be the strategy that we will adopt. So for the fifth question, the decision maker can adopt a strategy S2. So this is how you can find the strategies for the decision making under uncertainty. Thank you.